Here we go. So we're live today. We're back with another Infinite Layers, and we're back with another team that's building on EigenLayer. And today I'm joined by Fermah, and I'm joined by Vanishree, and I'm hoping I pronounced your name right. So we're going to be diving into the world of ZK. So if you don't mind, please give us an introduction to yourself and what you are building and what you have built, I guess, with Fermah.
Amazing. Thanks for having us, Nader. And yeah, we are super excited to be building on EigenLayer, and we are building Fermah, the universal proof generation layer. And yeah, I'll start with my introduction, my background, and how this all led to us working on Fermah. My background is in cryptography. I was working on, for example, the MENA protocol for 4 years, pretty much from the first few, pretty much from the very beginning of MENA. I was there for 4 years, worked on the consensus protocol, worked on the ZK snark that is built in there. And my background also was in academia through doing PhD, where I studied theoretical cryptography at UCLA. My advisor's name is Amit Sahai. And yeah, over time, everything that I've done in various projects is around zero knowledge proofs. And prior to that, prior to doing my PhD, I'm originally from India. So I got into cryptography through zero knowledge proofs. The first thing that I learned about cryptography was zero knowledge proofs and the puzzle nature of it, right? How can you convince somebody that something is true without even telling them why it's true? The puzzle nature of it was so riveting that there was no course or anything when I was studying in India, when I was doing my undergrad, but we have this tiny library, and there were a couple of books, and went through them, and one of my professors gave me this very amazing book by Neil Koblitz on number theory, which is the underpinning technology of cryptography. And I, like a nerd, went through this whole book page by page over a summer, and since then, all I wanted to do was cryptography. I was studying electronics and communication, but I never got the hang of it. And all I wanted to do was cryptography. And then joined UCLA, and then I told you the story since then. And along the way, I've been a very product-oriented person in my mind to try to create value, to try to see where the gap in the industry is, constantly been trying to do that. And I've tried to iterate on problems that are worthy enough to go after as an entire project and putting decades of your life behind.
Totally.
And finally came across this problem, and where the world is getting ready to embrace zero knowledge proofs. But if you look at projects that are embracing zero knowledge proofs, there is this pervasive and deeply felt problem across these projects, which is how do you build a network of provers? How do you incentivize this network of provers? You need to design and implement and maintain those incentives, and you need to make sure these incentives are optimal. You don't want to under incentivize, whereby you'll risk liveness because there will be attrition. You don't want to over incentivize because somebody needs to then open up their pockets, and it's typically the end user, so you're cost inefficient. You need to build this optimal incentive mechanism, and projects end up having band-aid solutions to this that are embracing ZK, because it turns out it's a project of its own. Right? it isn't that easy to do when there are other priorities for the businesses. These projects, for example, that are building roll-ups,
Mhm.
they have their own business priorities, right? This becomes a context, not the
Yeah.
core.
Right.
And
This is kind of, would you consider an
exactly
implementation detail of
right.
like the product that they're trying to build almost?
uh, an implementation detail.
For a
um,
feature or like a, yeah, of the product, or a differentiating
yeah,
feature or factor maybe, or just something
I,
like
I
that.
I think more of a necessary factor for anything that they're building. And because it's a necessary factor, hard to do across all these projects, this is one of the many reasons why it is better done by a separate project like ours in a universal manner, where there is one effort that we put in building these incentive structures, working on EigenLayer and building that out, and offering this proof generation layer to all these projects where they get this very clean SLA guarantees, as clean as possible for proof generation on proof generation time or proof generation cost. And then this is a specific headache that we try to take away, right? There is a specific headache in the industry that we want to take away, and this is how we want to begin by doing that. But this is where we are beginning. But our main end goal, our vision, is to make ZK the main substrate of any computation. It is becoming the substrate of many computation. We want to make it the default substrate of computation. And one of the main pain points right now is this proof generation layer that people are having to build. Right now, people are building in a band-aid solution. Now we are building it in a universal manner that all these diverse demands can take advantage of, right? At this point, I also want to highlight one other main advantage of building something like this, and that is um, a very good utilization rate of these provers. They come here, projects come and go in terms of, when somebody's building a startup, it may or may not work out, and they may pivot to something else. But when they are working on ZK, they can use us. And for these provers, they have this kind of consistent demand from diverse uh, uh, demand points instead of just one single project. This is yet another important reason why something like Fermah should exist. Yeah.
So, I have a bunch of questions, but to kind of go back, if someone was to kind of say, what's the TLDR? What is the succinct elevator pitch for what Fermah is? What would that be?
Universal proving layer. For
Got it.
anyone who wants to embrace ZK, they don't need to worry about proof generation. They just delegate proving tasks, they get proofs.
Got it. This is very much, I think a lot of the stuff that you're kind of talking about is very reminiscent of kind of how the cloud era has really taken a hold of most software engineering teams. And like, if you're building a product, you don't go and you build out these really intense
Exactly.
like infrastructure pieces from scratch. You kind of find something that's been built and optimized and specialized for, for years by a team that's focused on that. And then you just kind
Right.
of say, I want to grab this high performance NoSQL database because someone's been building it and optimizing it for 5 years. It just doesn't make sense for me to go and rebuild that from scratch. So this is
Exactly.
essentially like the ZK version of that.
Exactly. Exactly.
That makes sense. And I think some of the language that I see in the documentation, and kind of going through some of the papers and stuff that you all have, it's talking about kind of a marketplace. So there are different types of like proof systems that you can choose from and utilize. Can you talk a little bit about that?
Yes, that's a great question, Heather. Um, I think I've long held this belief that there will never be one single winning proof system, because different people want different things. Some projects want cost; they care about cost. Some other projects want proving time. some to be what the thing that they want to optimize for. Some projects want memory requirements. There are different requirements that different projects want, and there can be different proof systems that can cater to these different requirements. And this is why we are not building yet another proof system or a ZKVM or a ZKVM, but we are focusing on one single goal for now, which is make proof generation easy. And because the world will probably never choose a winner in terms of proof systems, we don't want to do that either. That is why we're building a universal proof generation layer where anyone can deploy a proof system of their choice. And whenever they have proof generation tests, they can give it to us, and we will orchestrate in the right manner in the background. And all they see is that they give proof generation tests, they get proofs generated. Right, and we do it. And you mentioned marketplace, and the reason why I think this should be a marketplace and not a single entity generating proofs is because of the following. So I have a thesis, and it may or may not work. I'll tell you my thesis and how our product can work for that. But I'll also tell you what if my thesis does not work, and how our product is thesis. It's resilient to the thesis changing. That is how we are building it, right? My thesis is that proof generation. So ZK, I believe, is going to become a lot bigger than blockchain. Many people hold this belief, and the reason is that ZK brings value even to parties that are best centralized. Even there, it brings value. And it has such a generic efficiency contribution that it can be used even for people who don't believe in the ethos of blockchain. This is why I think ZK is very primed to have a very huge adoption. And when such a huge adoption happens, you want to build your system that is scalable. You want to build your infrastructure that is scalable. The architecture needs to be scalable. And if you start off building your skeleton to be centralized, then it becomes very hard to scale. Instead, if you start off with the skeleton so that it can scale, like marketplace, where the supply can increase with increase in the demand. So we are better positioned to the future, where ZK can reach those inflection points and generate proofs for the world. This is why we are building a marketplace. Imagine a situation where I'm wrong, where marketplace isn't the right way to go here. Maybe there is a cluster of machines that are best set to do it. That's fine. That is where we will go. If the world tells us that's the place, that's how we should generate proofs, we'll generate proofs. Our goal is very simple. Our goal will not change. We want to take away the headache of proof generation from people. And how we do it, we can keep changing depending on how we learn what the world wants. But we are starting off with the marketplace because we want to be primed to. We want to be set for a future where a marketplace is the right answer, but it's easier to go to a centralized way than the other way around.
So in terms of the marketplace, is the marketplace a marketplace of various types of proof systems, or is it a marketplace of actual like GPU and CPU and compute?
Amazing question. I think we want to simplify the framework here. So the framework is just that it's a two-sided marketplace. There's demand for proof generation, and then there is supply, the compute for proof generation. And there is this. So if you look at our architecture, we call the folks who want proofs to be generated as proof seekers, because proofs is truth. So truth seekers kind of that's the way we coined that word for people who want proofs requests. And then there are prover nodes on the other side, and in the center there is this matchmaker, right? The main orchestrator that we are building. Like we were discussing earlier, there may not be one single proof system. So we want to be able to generate proofs for any proof system. So there are options on whichever proof system these projects, these seekers want to choose. So let's say they choose proof system 1, they deploy that proof system, and there are these machines on the supply side. They subscribe to certain demands, and depending on their business choices and also depending on their ability to cater to such demand. This demand can have some minimum requirements on memory, compute, etc., bandwidth, and they need to meet that requirement. And besides that, if they have any other requirements, they'll account for that and subscribe to some subset of demand. So they'll choose let's say we have integrated 50 proof systems. There is someone on the supply side, they'll say, it really makes sense for me to work with a proof system that, and that. I will subscribe to the demand from there, and we take note of that in the matchmaker through EigenLayer smart contracts. We note that down, and every time there is a proof request, we have this subset of supply that has subscribed to that demand, and we have the further subset of who is available, depending on who already is doing some work and who is available. And we of course also make sure that they have that minimum hardware capacity to handle the demand, and then we delegate proof generation. So I think your main question was on the way we look at how the architecture should be from the marketplace point of view. But this is how we are looking: marketplace, two-sided marketplace, option on proof system, subscription on the supply side, and one thing to highlight at this point is that the way we are working on EigenLayer is by bootstrapping our supply side using EigenLayer operators.
Makes sense. So do you all have any opinions around the verification of proofs, or is it just around the proof generation?
I think we wanted to, so I think it was someone from the Y Combinator. They said that when you're a startup, or was it Nawal? When you're a startup, you want to do only one thing at a time, and we just want to focus on that now. I think it's a project in itself. Like I said, it's a project in itself, and we want to do it well. There are so many mechanism design questions that we are very actively working on that we want to get right. The results of which will really cater to the demands, to the requirements of our customers. We want to do this right, and we want to focus on this, and we don't want to dilute our attention. We just want to get this right first, and let's see what the future will hold later. But laser focus there right now.
Got it. That makes sense. Okay, cool. So I've been going through some of your documentation, and it looks like that you have a couple of different types of nodes. And I think you already mentioned the seekers, but it looks like you have the seeker nodes, the prover nodes, and the matchmakers. You mentioned some of this, but do you want to kind of dive a little bit more into that? Because this seems kind of interesting to kind of understand a little better how the system itself is architected.
Perfect. Yes. So think of someone who, so let's start from the point of view of someone who wants a proof to be generated. They become the seeker. So in our architecture, like you said, we have three components: the seekers, the prover nodes, and the matchmaker. So they become the seeker. And what they do next is they deploy a proof system if it is not already deployed. They deploy a proof system in a very easy manner. They Dockerize their prover, they Dockerize their verifier, and deploy it. It's very simple way of deploying proof system. And then, so that is what the matchmaker will see. Okay, there is a new proof system that is deployed. Takes note. Also sends that information to the supply nodes, allows them to subscribe to the demand for this proof system. So this is step one. This is kind of a setup part. And then every time this seeker wants a proof to be generated, it sends a proof request. There is also a pointer to which proof system. So we know which proof system we want to invoke, which prover verifier we want to invoke, which prover verifier we want to invoke for this proof request. So they have this pointer. Okay, this is the proof system. Grot16 is the proof system I want to generate proofs for. I've already deployed that proof system. Here is my proof request. Generate proof for it. So they send it to the matchmaker. Matchmaker, like we just discussed, the orchestration mechanism looks at who is available, who can generate Grot16 proof, and who is willing to generate Grot16 proof, and goes and gives the proof request to one of them. That person generates the proof, gives it back to the matchmaker, and we have some interesting inner. There are some complexities of how we can make proof generation fast and how soon we give the proof to the supply, but barring all that complexity, it's simple way people can go through the docs for it. But I'll say what happens now. So proof request has gone to the matchmaker. Matchmaker assigned the proof request. Proof got generated, came to the matchmaker. Matchmaker verifies it and sends it to the proof seeker or a callback that they have specified. Now, you had an interesting question just a while ago. Do we cater to verification? I said no, but why are we doing this verification? We are doing this verification because we want to make sure that we have done the work. It's not like we are a settlement layer.
Mm-hmm.
Us saying that we have verified doesn't mean anything to the external world, the world
Right.
beyond the seeker.
Got it.
It's just is that
the work has been done.
Exactly. That's it.
Got it. That makes sense.
Yeah.
So with all of this in mind, this is kind of going beyond Fermah specifically, but maybe not so much. What types of use cases, products, protocols, what are the things that you kind of see being built on a layer like this and enabled?
Yeah. Let's start with something that has already become a lot more popular than the other categories, the ZK rollups, the ZK bridges, and ZK coprocessors. These are specific use cases of ZK. And there are some really interesting projects that people are working on, like gaming. People are working on generating proofs that proof of identity, like you want to prove that you're over 21 years of age without revealing your exact date of birth, for example. There are and this can be useful in so many ways. Billions of dollars billions of dollars that is now spent, that is now wasted because people's identities are getting hacked, because people are having to write their SSNs on PDFs and send it over emails. You don't want all of that. We are, I think, all building these tools for the world to be better. And I think we are all building these parts of it, and very soon we will see that, oh, there is a complete puzzle. And I think we may not even realize that we are part of this one single puzzle, and we are building these parts of the puzzle. Like, for example, we are building the ZK infrastructure layer. Somebody is building something for identity to get on the blockchain while keeping some part of their credentials secret. And all of this can eventually save billions of dollars where people are not having to put their identity information out in the open for it to get hacked. For example, right? I think the expanse of use cases is enormous. What else comes to mind is that I'll give you another very interesting work. I think Dan Bonet did it. They did this work on proof of. So I think they worked on. So when people are doing criminal journalism, so when you take a picture with your camera, with modification of pictures and videos being so easy these days, how can proofs like that stand in the court of law? You can use zero knowledge proofs. Kodak can put in their hardware these boundaries of what can happen inside the machine, and it can create signatures, create proofs of whatever happened inside the machine, and whatever comes out, you know that it hasn't been meddled with, or any transformation you have made, you can create a proof of that transformation. Look, this is what came out of Kodak camera, and you have a proof of that, and I will give you that, and I will also give you a transformation of that. Maybe I needed to enhance it in some reason to make it more visible, but this is the exact transformation I've put. I haven't made any other transformation, and here is an additional proof, and this can potentially stand in the court of law. I think this is why I think I'm a huge believer that ZK can become so much bigger than blockchain. Look how big signatures are, because of its really generic, powerful ability, that it just says that you give people the ability to attest to things. That signatures, digital signatures, it's such a generic and powerful thing. And ZK is also this generic and powerful thing that it can become so widely applicable. There is another application of proof of solvency. Banks can continue to prove that they are solvent without telling people exact inner details of their transactions happening, people's identities, people's specific transaction. They can create proof of solvency that their customers can look at to understand who they are banking with, what kind how solvent their banks are when they're banking with them. I think the applications are just enormous, but I think we are starting. Like we were discussing, we were starting at ZK Rollup, ZK Bridges. That is where we have had a lot of adoption.
Got it. That makes sense. So if someone was to say, I want to build a rollup, and I want it to be a ZK rollup, but I want to have maybe all of this specific functionality, they could then go and choose what would ever be potentially maybe the right proof system that is supported with Fermah, and then they could essentially just integrate it pretty easily, as opposed to having to kind of build anything from scratch.
Absolutely. Yes.
So like if a developer wants to start using Fermah, I see that there's like a CLI, and I'm just curious, what does the integration kind of look like right now? And also, where is Fermah in terms of the product lifecycle, testnet, devnet, mainnet, stuff like that?
Right. Right. Let's start with, I think, the stages of project, and then I'll explain how people can get involved in this stage of the project. We are on DevNet, and it's permissioned. We have whitelisted some amazing set of operators who are very passionate and are helping us, and we're slowly starting to onboard seekers who want to come and test our network, maybe perhaps deploy new proof systems and test our network. We have the CLI. I think our docs show how to apply to get whitelisted, And then once we communicate, yes, you're whitelisted, we are done with our side of our work, and then there are very clear instructions on how they can get set up on their site to be a seeker or an operator. Yeah, this is for our DevNet, but our testnet is also going to come in the next few months. But this is for our DevNet.
Okay, got it. So essentially, if they want to get allow listed, do they just reach out to the team somewhere on the
Yes, I think
website?
yes. On the website, there is a form. They can go ahead and fill out that form, and we will get in touch with them to handhold them, and we will help them out through the onboarding process.
Okay, got it. So with the supported proof systems, those are all essentially live and available on the DevNet?
Yes, that's
Okay,
right.
cool. So Jolt, Groth 16, Risk Zero, and a few others.
And a few others, and more to come. We're constantly adding more proof systems.
Okay, yeah, and that's another question. So to add a proof system, is that something that the team does, or is that something that someone can come in and submit their own proof system? Or is it maybe?
Initially, it's both. I think initially we have done it ourselves for many of these proof systems, because so what happens with these specifically CKVMs is that they are at different stages of their development, and it might be harder for a project to entirely figure out how to get their those proofs and verifiers exactly, and which part of it to Dockerize, etc. We have done that prior work, so that anyone who comes and tells us, okay, this is a specific proof system we want to integrate, we know exactly how to handhold them and make it easy for them. But in general, when you have a prover, when you know this is the proof system I want to work with, this is the prover and this is the verifier, then it's a very, very, very simple process to just Dockerize and deploy. It's a very simple process.
Okay, that makes sense.
Mhm.
Okay, cool. So what are the plans for Fermah over the next maybe like 6 months or so?
Right. So we are right now in DevNet, where we are testing the network, rigorously testing the network, stress testing, making it fail, and getting it better, iterating, getting feedback from seekers and operators. And in the next few months, we want to start our testnet, feature freeze, and test in the real world how our network can be stable. That's one of the two main goals we have. The other goal we have is we are going to build out the mechanism design. Right now, DevNet has the core functionality of taking a proof request and orchestrating it to an available supply node per their hardware availability and capability. There is, so we are like I was mentioning earlier in the call, one of the main focus areas for us is designing the mechanism of orchestration. So this mechanism design will get implemented, and we are glad that so the pace of EigenLayer's product is very amenable to our. Every time we need something just before then something you have released, for example, slashing and payments. These are the things that are getting in there, and this just really really matches our timeline of when we want to implement our mechanism design. That'll make use of these features from EigenLayer. Yeah.
Okay, so to move away slightly from the discussion we've had, I'm curious, what has it been like to be a founder, and what has that experience been like so far? Because I'm always interested to hear, because people come from so many different backgrounds, and your background sounds unique, as you know, do a lot of people.
Yeah, I think it's been enthralling. I think this has been the most dense learning experience I've had. even more than PhD. In PhD,
Wow.
yeah, in PhD, I had to dive deep. I thought that it can't get more intense in my learning experience, but this has been insanely um, uh,
Intense.
enabling in my growth,
That's
intense, but
awesome.
in a
That's
very good
amazing.
way.
That's
But
a
in a very
positive.
good way.
Yeah.
Yeah, yeah. It's very energizing. That it also is good that we constantly see that whatever we are doing is towards the right direction, because every time we go closer to our goal, we see people uh, um, looking to use what we are building. So it is very energizing. I think I've always wanted to create some level of impact, and to have found this problem, which is very close to me, because since my childhood I've been obsessed about zero knowledge proofs, and uh, to build something here, which I strongly believe is an open problem, and believe is going to move the needle in our industry. I think it really is rewarding so far. We just very we are a baby still. I founded this company late last year, um, so we are very early, but still this has been incredible, and
So
it's
you're
great to
almost
build
at
on
1
Icon.
year.
Huh?
Yeah, so you're almost at 1 year. So that's a good
That's right.
benchmark, I guess you could say, or a
That's right.
milestone.
Yes.
Cool.
Infant still.
Yeah, yeah, for sure. So I guess we'll touch on now the eigenlayer specific stuff. So you kind of touched on why you chose eigenlayer, but what has the experience been like building on eigenlayer? And do you have any advice, I guess, for teams who are kind of getting started building an ABS?
Yeah, I think so. When we started, when we decided to work with EigenLayer, it was because we saw EigenLayer to be a piece of the puzzle, and as another piece of the puzzle. It really fit very well because our mechanism design involves our approach to mechanism design is to incentivize the provers through staking and slashing. Right, that's how we incentivize them to behave per their commitment, which is important for liveness guarantees that we give on the demand side. This is our mechanism design approach. And what EigenLayer offers just clearly is the other piece of the puzzle. It helped us go faster in building this, because EigenLayer has this network of operators and has these middleware contracts that'll help us do all these mechanism design through staking, etc., much faster. And this is why we decided to work with EigenLayer. And so you also asked how it's been, how the experience has been to work with EigenLayer, and any tips. So I think the experience has been product-wise. We knew from the very beginning that that EigenLayer, building on EigenLayer, having EigenLayer as a part of our tech stack, will be beneficial for our product, and it has been that way. It has helped us go faster, and the experience has been positive. The team that you have is helpful. I think I would want to give a shout out to Nima, who was there from the very beginning and who helped us build that initial architecture, and was a very strong present sounding board. And my tip thereby is that for people who want to build on EigenLayer, I think it helps to kind of navigate. You're a big project now, much bigger than even when we started. It'll be good for them to navigate who to talk to for what from the get go, and I think have a direct line with Nima as much as possible. And Nima, I think, is an amazing. He's just very smart, and he can think for other projects' requirements. He doesn't just think from the EigenLayer's perspective. He just becomes a team member when he talks to you. So I think that those would be my tips.
Yeah, +1 for Nima, and I think just +1 for just being proactive to reach out to us because, like you said, we are pretty busy these days, and we try to prioritize everyone. But if the squeaky, where they say the squeaky wheel gets the grease or whatever, like if you need something, just ask, and we'll always try to do our best to kind of answer and bring in the right folks. And yeah, +1 on Nima if anyone is watching and
Right.
it needs someone amazing to be in the group chat with them. Let me know, and I'll add Nima. But
Mhm.
yeah, this has been really informative and really helpful for me. I saw that you had another interview recently on the Roll Up podcast. If anyone's
Yeah.
watching and you want to learn more, definitely check that out. But where else would you say to go for people to kind of learn a little bit more about Fermah if they're considering, if they want to kind of actually utilize what you all have built?
Amazing. So we are in New York City for the CSX A16Z CSX cohort for the next month or so. We'd love to meet people in person if folks are there. And just in a couple of days, I'm going to ZK Summit to give a talk on some of the open problems in the ZK space, and I have so many other problems, and would love to jam with people who are interested in the space at ZK Summit in Lisbon. And I think we will also be at DevCon. I'll be giving a talk at DevCon. I think 2 talks at DevCon, and that'll be fun. Will be great to meet with folks there. And yeah, people should feel free to DM me on Twitter. And we really like collaborating with people who want to embrace ZK, and we want to be of value. We also want to so think of us as a credibly neutral layer, but not only for generating proofs, but also for testing proof systems. So we have integrated all
Interesting.
this proof systems. So come,
That's pretty
you,
cool.
yeah, yeah, yeah. And here is another reason, right? So this is very interesting. Why you want to have a universal proof generation layer is because infrastructure is hard to change, and you want to build if you build when you're embracing ZK, you build your architecture, right? You want to build your architecture in such a way that you can switch your proof systems, because the breakneck speed at which the ZK space is moving, you don't want to marry too early your proof system. You want upgradability as part of your architecture, and then comes the infrastructure. If you're working on a universal proof generation layer, you can switch your proof system but still stay on the same infrastructure layer, so your switching cost is very low. Yeah. Anyway, this is a very important point. It's somehow connected to what you're saying, but I
Yeah,
just put
totally.
that plug in.
Okay, very cool. And then as far as the developer community is concerned, is there a Discord or a Telegram yet?
Yes, we have Discord and Telegram. I think there should be a link on our website and on our Twitter, also on our Fermah_XYZ Twitter. There are links to going to our Discord and Telegram. But if anyone finds it hard, they can just DM me.
That's so cool. Yeah, you can just DM the founder. Like that's amazing. Cool. Well, thank you so much. This has been really, really helpful and interesting to me. I learned a lot, and I'm hoping a lot of other people did as well. And I wish you the best of luck, and I'm looking forward to seeing you at DevCon.
Thank you, Nader. It was a pleasure.